Bismillah, Assalamualaikum warahmatullahi wabarakatuh. This is Statics, chapter 6.4, the method of sections. Now, this chapter will still focus on the structure called trusses or truss. The difference is between this and the previous subchapter is that we are going to use a different method, which is method of sections. Previously, we have learned how to use method of joints. So we are still trying to calculate the same thing but using different method, and we will cover some of the slides that will emphasize why this method sometimes is easier or more necessary compared to method of joints for certain problem that we have or certain things that we want to compute. If you need the slide, perhaps it is best that you have the slide as well as going through this lecture so that you have it side by side. You can download the file in the description box below. Right. So the objective for today's lecture is for the student to be able to determine the forces in truss members by using the method of sections. These are some examples of real life structure that is basically an example of trusses. So it is stated here that method of joints requires that many joints to be analyzed before we can determine the forces in the middle of a large truss, right? So if you still remember what we have done, solving truss problem, when I'm saying truss problem, I mean the structure truss, right? No, I'm not saying that we do not trust each other. If you have a big truss where we have a lot of members, and then we want to find what is the force in the member at the middle, right? So if you still remember method of joints, for example, you solve the support action first at the end, and then you go from joint to joint to joint to joint to joint until you reach where you want to solve, right? So basically you have to solve a lot of members before you reach the member in the middle, for example, right? So it requires a lot of calculation before you get to the value that you want. But method of section, you can straightaway cut where you want and then straightaway compute the force in that member, right? So that is where it is very helpful to also know this method of section. Additional point, in chapter 7, when we deal with internal loading, internal force, it is, the understanding of method of section is critical as well for you to be able to solve in chapter 7, but more on that when we go into chapter 7. So imagine that we have the structure here, right? And basically the idea of method of section is basically we cut the truss into two portions, right? So basically you have to decide where you want to cut, and it becomes two sections, right? So you section it and become two sections. So in a method of section, a truss is divided into two parts by taking an imaginary quote-unquote cut, and it is shown there at the blue line AA, right? So since truss members are subjected to only tensile or compressive force along their length, the internal force at the cut member also will be either tensile or compressive with the same magnitude as the forces at the joint. This result is based on the equilibrium principle and Newton's third law. Now, why we can use this method of section is because trusses by definition is a combination of two force members. And hopefully you still remember this, because when we introduced truss before we go into the method of section, method of joints, we have defined what is a truss, and you should already know what is a two force member. Now this will be different, and what we'll be doing by analyzing trusses using method of section is not applicable if it is not a truss. If it is, for example, a frame, it will be different, right? So this will only valid for trusses, because why? For trusses, each member is a two force member, hence it can either be in tension. So for example, if the member is like this, it can either be in tension or in compression. There will not be any forces in any other axis, right? So that's why this method of section can work for trusses. For frame or for machine, you cannot use this method. Hopefully that's clear. I'm keep repeating the same thing. I think I'm just emphasizing. Hopefully you can process it and do not make a mistake of using a method that is not applicable for different structure. Now we are still using the same example or structure as an example. When you cut at the line AA, the blue line AA there, basically it becomes two segment, right? So, and you can refer to the slide, but I'll try to put it here as well. Maybe it becomes smaller. So you have on the right side as well as on the left side, right? And you can solve both way, meaning that each side will give you or should give you the same answer, right? So we'll go through the steps for analysis. Number one, decide how you need to cut the truss. This is based on A, where you need to determine the forces, and B, where the total number of unknown does not exceed 3. Because in 2D, now we are still focusing on 2D, right? So in 2D, basically you have 3 equations for a free body diagram, right? So for one free body diagram, basically you can solve up to 3 unknown, generally speaking. So basically you have fx, fy, and moment equal to 0. But of course you can have summation of a moment at different points as well, right? But up to 3 unknowns, generally speaking. So it depends how you want to cut, where you want to cut. It depends on normally the question. For example, the question say, find, if you look at the original diagram first, it says find what is the forces in member CG. Then obviously you want that member to be cut, right? Because then you can know that forces. If the question say find the force in member DF, you will not cut it this way because you will not get what is the force in that member, right? So this is just to give you an idea. So in this way of cutting, you can determine what is the force in member BC, CG, and GF, right? So that's how, meaning if you the question asks for a different member, you will cut it differently. That's number one. Number two, obviously if the question asks for 4 or 5 unknown, maybe you cannot solve by just a single cut. Maybe you have to do different cases, right? So for these 3 unknown, you cut it this way, and then you solve the other unknown with a different free body diagram, perhaps. Okay, that's number one. You have to determine how to cut, where to cut. Number two, decide which side of the cut truss will be easier to work with. Now, either way, you should get the same answer. It's just that one side can be longer or more difficult to compute or calculate compared to the other, right? So that's where by exercise or just by understanding and looking at both sides, you may be able to determine, okay, maybe it's easier to take the left, for example, right? Number 3, if required, determine any necessary support reaction by drawing a free body diagram of the entire truss and applying equation of equilibrium, right? So as we have done with method of joint, it's the same, right? So for example, for method of joint, either you want to start at this point or this point. If you have any part where you can straight away start, because the number of unknown there is 3 or less, sorry, for method of joint you have 2, right? Because you focus on a point and you have only fx, fy. But here, because it's not a point, it's a rigid body, right? So you have 3. So for example, if you look at this diagram, when you cut it that way, on the left side, you can straight away use that 1000 Newton force to calculate the unknown, and you have 3 unknown there, right? And if you look at on the right side, you have the support action of dx, dy, as well as ex. So if you want to use on the right side for this problem, you have to solve the support action first. And how to do that? You draw the full truss and use the 1000 Newton to solve the 3 unknown first, the 3 support action first, and then go to the cut section on the right and then solve. So you actually have to solve 2 free body diagram. But if you want to use the left one, you can straightway go there, because you can straightway use that 1000 Newton and the 3 unknown, right? So hopefully it is clear that, you know, sometimes both way you have to still determine the support action sometimes. So it depends, right? As long as you understand what's going on and what you need to find and what is the implication, you should be able to make the right decision. Right, after that, you just solve the side that you selected using equation of equilibrium, and then you'll get the unknown, right? So that's basically the steps for analysis. Now, a reminder on how to draw the free body diagram, right? So just like when we draw the free body diagram for method of joints, where the direction plays a role and you have to understand how you draw, what it means, right? Either this means it is in tension or it is in compression, right? So for example, what some of you might want to just assume everything is in tension, the force going out. If you get negative, it means it is compression, right? But in this diagram here, if you see, the left side, actually it draws FBC, FCG assumed to be tension, while FGF is drawn in compression, right? So you can see that, of course, the right side is the same in the sense that it is just corresponding. So 2 force is assumed to be in tension, 1 is in compression, as shown there. That is an assumption, but of course, if you have done enough exercises, you can really make an educated assumption, right? So as usual, free body diagram, hopefully you understand what is a free body diagram, what have to be there. The forces, the known forces, you have to have the value in the free body diagram. The unknown, you have to label it properly. The dimension, the distance, put it there. Alright, okay, now we go to the first example for this class. So the diagram, I'll put it there. Of course, you can refer to your slide. So we have the truss there. It seems like a normal bridge type shape. There's a lot of member there. So if you want to solve this using method of joints, it will take a lot of iteration of calculation, right? So in this case, especially when the question say find the force in member KJ, KD and CD, the question only bother about these 3, right? So but it's quite in the middle, right? KJ, KD and CD, right? So if you want to use method of joints, so for example, if you start from the left, from point A, and then you have to solve point B, point L, and then point K and C, only then you reach all the 3 forces you need to determine, right? Hopefully you can imagine without me showing what's going on if you are to use method of joints. But now we are discussing on method of section, right? So I think by looking at the diagram and knowing the question asks for force in member KJ, KD and CD, it is quite obvious that the position that you need to cut, right? So obviously it is cutting the member KJ, cutting the member KD and cutting the member CD is just one straight line there, right? So if you imagine that you cut at that point, you will left with 2 sides, right? So on the left side and on the right side. Either way, by looking at it, you should be able to tell, right? Either way, you should still solve the support action first. Otherwise, you will have more unknown, because when you cut there, you already have 3 unknown from the 3 member being cut, and also you have unknown from the support action, so it is more than 3. So you cannot solve. You cannot solve unless you first solve for the support action. Hence, either way, we have to solve for support action first. So let's do that, right? So how to solve for support action? So in this example, number 1, solve support reaction, right? And how to do that? So we'll have the whole structure here. Okay, you can, yeah, how many there? Something like that, right? Like this, the whole thing there. And then you have a pin at A, so you have pin here, so AX, AY. Hopefully you can see clearly. Okay, there's some light there, right? So hopefully you can, okay, hopefully you can see. So AX, AY, and then you have GY there, right? Or normal force, because there's a roller, right? And then you have the force at point B, C, and D. So you have, where is it? Here, 20 kilonewton, 30 kilonewton, 40 kilonewton. Okay, so my drawing is too small, hence it becomes too tight like that. What else? So you have the height is 3 meter. Each of this length is 2 meter, right? So this is 2 meter. This is 2 meter, this is 2 meter, and this is 6 meter, right? So there's nothing there, so I'll just combine it. So 2 meter, 2 meter, 2 meter, 6 meter there. And what you want to solve here is AX, AY, and GY. Now, if you go back to the diagram there, and you already can imagine where you want to cut, and you already decide which side you want to solve. So if you want to solve on the left side, then you only need AX and AY, right? But if you want to solve using the right side, you only need GY, because you already will cut here, right? You will cut here. So if you took on the right side, obviously this is what you need. If you take on the left side, this is what I need. But we will solve all, because we will try to solve using both left and right, and see and prove that it will give you the same answer. Right, so let's take summation of moment about point A equal to 0. Let's take counterclockwise as positive. So take moment here. So GY will create counterclockwise. So GY, and then distance of 6, 8, 10, 12. So 12 meter there. And then, okay, this one, no. So this one will create clockwise. So minus, you have 20 times, take moment from here, right? 2 minus 30 times 4 minus 40 times 6, right? 2, 4, 6 equal to 0. From here you can solve for GY. If solve for this one, what do you get? Do verify, you should get 100 over 3. 100 over 3 Newton, or sorry, kilonewton, right? The unit kilonewton, or 33.33, right? 33.33 kilonewton. Obviously here we already introduced an error when you round up, round off. So it's best if you have more significant figures or significant numbers, so that the error will become minimized. This one doesn't have any error, right? It's because this is the whole value. Anyway, and if you have solved this one, so if you do summation of fx equal to 0, actually summation of fx doesn't need the rest, right? Because there's nothing there, so you'll get ax equal to 0. So you can start with this first as well. Okay, I'm out of the frame. Okay, and then summation of fy equal to 0 if you take upwards as positive, so you have ay upwards, and then minus 20, minus 30, minus 40, and then plus this 33.33 equal to 0. Then you can solve for ay, which is, if you solve, you get 56.67. 56.67. Is it negative or positive? Positive, yeah, because it should be upwards, this should be upwards, right? So this is kilonewton. So these are the support reaction. Ax is 0, ay is 56.67. Actually it is 56.666667, right? If you do not or 66 if you do not round off, right? So, and this one gy is 33.33. So take note of these values because I will erase this so that we can use it for the subsequent calculation, but hopefully this is what you have done before. If something here seems new, I'm worried because we have covered this before, right? This is exactly, if you want to use method of section, this is the step for solving the support action. If you want to use method of joints, we have covered earlier, this is the exact same thing that you have to do as well. So nothing new here. Now using this value we will cut, right? So basically I'll just draw it here, right? So where we will cut is here, right? So which one do we want to use? So let's use both, but we'll try using the left one first and then the right one, right? Now make sure when you want to draw, it covers the whole thing, right? All these forces as well, here as well, right? So sometimes we know how to do the steps, but sometimes when we are rushing and then we draw this segment, we have the force from the member, but we forgot something like this, for example, right? So avoid mistakes like that. So this is solve support action. That's number one. Number two, we will solve for the forces that we want. Now here let's using the left side. So we'll take the left side. So the diagram I think I'll leave it there. So if you draw it until that line, right? So basically like that, and then you cut there, right? So here you cut it there, here you cut it there, and here you cut it there, right? So let me draw the force in red. So we have solved for AX and AY, right? AX is 0, AY is 56.67, right? So here, okay, which is this clear, this color, or better to use? Okay, I'll use red for the force. So AY is 56.67. okay, this is running out of, okay, I have to use it smaller. Okay, this one is 20 kilonewton, so this is 20 kilonewton, this one is 30 kilonewton, right? And then if I assume everything is tension, meaning everything is outside, it will be like that, right? So that is FKJ, that is FKD, and that is FCD, right? Okay, so the height is 3 meter, this is 2 meter, this is 2 meter. If you do dot until this point, this is 2 meter, right? Now why do I add this point? This is not part of the structure, but it is beneficial to take summation of moment about this point, right? Yeah, so there's 2 points that will make it easier. One is taking moment here, then you can straight with calculate for FKJ. One is taking moment here. This is point D, right? This is point D, this is point K. Okay, so let's take, which one do you want? Okay, let's take moment about point K, for example, right? Summation of moment about point K equal to 0. Let's take about point K. Let's take counterclockwise as positive. So obviously this 2 goes through that one, it doesn't produce any moment. FCD does, so CD times the distance of the height is 3, this height, and then this one is clockwise, so minus 56.67 with a distance of we're taking K here, right? So 244, and then this one will be counterclockwise, so plus 20 times 2 this distance, and this 30 is going through K, so no moment there, equal to 0 here. So if you solve for FCD here, you should get 62.2 kilonewton, 62.2 kilonewton. Because it is positive and we assume to be tension, so it is tension, right? Just checking, this times 3, minus 56 times 4, plus 20 times 4. Okay. Now, as I mentioned before, now if you have this already, you can use summation of, because we already have this one, right? So you can use summation of fx and summation of fy actually. Now, one thing that we need is, when we want to calculate fkd after this, is the angle, right? So given that this height is 3, this length is 2, the triangle that it makes, if you make this triangle here, it is, this is 2, this is 3, so 9 plus 4 is 13, so square root of 13 here, right? That is the triangle. So what do you want to do? I'll take moment here. I think the slide will use, I'm not sure, you can see which equation the slide use, but any which equation that suits you. So I'm just showing one example, right? So summation of moment about point D equal to 0, if they counterclockwise as positive, you take this one. So fkj will become, so it's clockwise, so minus fkj times the distance of the height 3, we take about this one, right? So this one is clockwise, so minus 56.67 is distance of 2.2466, and then this one counterclockwise will become positive, so 20 times distance of 4, and then plus 30 times distance of 2 equal to 0. So fkj, if you solve this, so double check, 24, 32 minus 56, 6 minus fkj 3, then you'll get minus 66.67, right, kilonewton. And this negative because I assume tension, negative means compression. Okay, so one thing is left, which is the fkd, right, this one. So you can solve by using summation of fy equal to 0, taking upward as positive, for example. So you have 56.67 minus 20 minus 30, and then you have here minus fkd, the vertical component is 3 over 3 over 13 equal to 0. Is it okay? Okay, so if you calculate this one, fkd equal to, so verifying, 56 minus 20 minus 30 minus fkd 3 over 13, so you should get 8.02 kilonewton. Is it positive? Positive, so it is tension. That will be the answer that we need to find, right? So that is if we solve using the left side. Hopefully, if you have any question, put it in the comment section below, or if anything that you want to point out, do comment so that I myself and anyone else actually can be alerted if something need to be alerted. So comment in the comment section. All right, so we have shown how to, because this is the end of the calculation, but we also want to try to show what if we use the right side. Let's do that. Okay, so based on the same support reaction from the first step, what if we do not use the left side, we use the right side? So number 2, using the right side. So we'll have to draw the right side. So basically it is a bit longer. We have how many? 1, 2, 3, 1, 2, 3, and then the break, right? So 1, 2, 3, and then this one, right? Okay, so we have this, and then it's this way, right? Here, and it goes here, it goes here, and then where you cut, right? Oh, but it's this way. Right, so I'm using the red as my force again. So in this case, gy we already solved, which is, what was that? Gy 33.33 kilonewton, right? All right, what are the forces? So we cut at after D, right? So meaning that we have 40 kilonewton here, 40 kilonewton there, and then we have FCD. I'm assuming everything tension as well. FKD here, I'm using the same name, FKJ, even though the direction is different, but I'm just using the same name. All right, so this is 6, right? 6 meter, and again, there's 2 points that you can take. For example, if you want to use similar approach, this is point D, this is point K, right? This is point K, which is the same point as before, because that's the point that cancel 2 out of the 3 unknown, right? It's the same point. But it depends, right? So let's I'll use a blue color right now. So let's use point D. Okay, summation of moment about point D equal to 0 if I take counterclockwise as positive. So it cancel these 2, so we have FKJ counterclockwise, and then the distance, okay, this distance is 3, right? 3 meter. So it times 3 meter, the distance. And then no, this goes here, and then only here, right? So this one is counterclockwise, right? So plus 33.33 times distance of 6 equal to 0, right? Is it only that 2? Alright, so based on this, you can see it is going to be having a negative value, negative 66.66 kilonewton, meaning it is compression, right? Now there's an error here actually, right? Because I'm not taking enough significant figure. If you recall earlier, it becomes 66.67, right? So I think you can try here, you'll get this one because there's an error. So we have 0.01 kilonewton error between the 2 answer, right? Anyway, if you already have this one, let's say I want to use straightaway summation of Fy equal to 0 upwards, if I'm not going to use this moment, right? So what do we have? You have, okay, again, this is the same triangle. So this is 2, this is 3, this is 13, right? So you have summation of Fy, right? So FKD 3 or cert over cert 13, and then this is minus 40, and then this is plus 33.33 equal to 0. So FKD will be equal to, so if you do this, wait, did I miss something? FKD 3 over set 13 plus 33.33 minus 40 equal, so you get 8.02 kilonewton, which is in tension, right? And having this, you can actually use summation of Fx. Let's try to use that one, right? So if you use moment about k, you get the same answer anyway. So this is just to try. So if you use summation of Fx equal to 2, so you have to use this one, Fkj, so you get negative. Okay, now here's the thing. If you want to use this equation, just an example, right? Based on the diagram, you get negative because it's to the left, but the value is negative based on this diagram, so you'll have to put inside negative 66.66, right? Hopefully that you understand, because this means actually it is compression, right? Means to the right. So from here, if you know already to the right, it's actually going to be positive. But if you want to be consistent with this free body diagram, based on the free body diagram, this is negative to the left, but the value of this force in the free body diagram is negative. So it is negative, right? Okay. And then you have FKD. So also negative to the left. So FKD is 8.02, but you have the angle here, so 2 over square root of 13. And then you have minus FCD, no x, right? So equal to 0. So if you calculate FCD here, you should get, so minus 66.66 minus 8.022 over square root of 13 minus FCD. So you get 62.2 kilonewton, which is tension, because it is positive, and I assume tension, right? The answer should be the same. The answer should match with what we have shown before. So either way, I'm not sure, up to you, right? Which one do you think is easier or shorter, taken on the left or on the right? So hopefully try both and you can see which one suits you best and why. All right, so that's the first example. Moving on. Okay, now we have a concept quiz. Refer to this slide, but I'm putting there also the diagram, but because you have to read also the question, right? Even though I reiterate the question, maybe it's hard to capture just by listening. Anyway, so the diagram is there, and then the question says, can you determine the force in member ED? ED, basically the slanting on the right side, right? Can you solve for force in member ED by making the cut at section AA? Okay, that line, right? Explain your answer. Okay, can you? Of course, if you cut at AA, it does cut member ED, right? So there are several possible answers. Number A, no, there are 4 unknown. How many unknown if you cut like that? Actually, it is 4, right? If you, because you cut AB, so that's one unknown. You cut BF, the second one you cut BE, and you cut BD. So 4 unknown. So that is possible. But answer B, yes, using summation of MD equal to 0. So if you take moment about point D equal to 0, can you solve for member ED? you can, right? Because that force goes to that point. You cannot solve. If you use summation about moment ME, you cannot also, because force ED goes through point E. Yes, using summation of moment MB. This is interesting because if you calculate moment at point B, even though you have 4 unknown, but 3 of the unknown actually goes through point B, right? So if you take moment about point B, you can actually left with 1 unknown, which is ED, and you can solve. So the answer is D actually. Right, so this is just to test you to imagine what is happening. Alright, so hopefully you understand that. Moving on to the next one. Okay, so this is still a concept quiz. The diagram is there, and you have all the forces there. So if you know FED, how will you determine FEB? Okay, so if you already know FED, how will you determine FEB? By taking section BB and using moment about point E. If you take moment about point E, you cannot solve for EB, obviously, so that's wrong, because FEB goes to point E, so you cannot calculate there. B, by taking section BB and using summation of Fx and summation of Fy equal to 0. That is interesting. If you cut BB, right, so you have 3 unknown, right? So FE, BE and DE. If you take, so you have 3 unknown and you solve for Fx and Fy. Can you solve it? Now, if you solve for summation of, because okay, sorry, you have 2 unknown, because ED you already know, right? Sorry. So you actually have 2 unknown and 2 equation. You can solve actually, right? So B is possible. Point C, option C, by taking section AA. Okay, section AA you have 4 unknown. Summation of moment about point B. Now, if you take moment about point B, you cannot solve for EB, because EB go to point B. If you take moment about point D, and you cut AA, then you have too many unknown. You cannot solve, right? So the answer is B. This is just concept quiz. Hopefully you can understand and imagine. Moving on, so we'll try to solve a example where you calculate something, right? So in this slide, this is group problem solving. So let's try this, right? So you have the diagram. I'll put it there. We need to find forces in member ED, okay, EH and GH. So hopefully you can straight away imagine how to cut, because obviously we'll cut ED, EH and GH, and it is separated into 2, right? And if you take a look, if I want to take on the left side, I have to know what is the reaction at roller first, right? And if I want to take on the right side, I have to know what is the support reaction at A, right? So which one do you want to use? Perhaps the left side will be easier, right? Because there's less force and should be straightforward. So let's focus on that. You can try both. The answer should be the same, but it is already almost 3 AM here. I'm already sleepy, so maybe I do not have enough energy to try both, unfortunately. Sorry. Alright, so let's go. And okay, again, you have to solve for the support reaction first, and if I want already decided on the left side, I just need to solve for F, normal reaction at F upwards, right? So how to do that? We draw the whole thing. So basically, how is this? Like that, right? So basically, if we draw the forces in blue, so we have the roller there, so Fy, is it F, point F there, okay. And then we have 40 kilonewton downwards, 40 kilonewton, and then we have 50 kilonewton downwards here, 50 kilonewton, and then we have 30 kilonewton to the left, 30 kilonewton, and then we have 40 kilonewton to the left, 40 kilonewton, and then we have AX and AY, which is a pin support, right. And we have the distance, so we have 1.5 meter each, so this is 1.5 meter, 1.5 meter, all is 1.5. What about this one? 2, 2, 2. Okay. Okay, put okay here, right? Oops. 2 meter, 2 meter, 2 meter. Okay. So if I already decided I want to take, because the cut is here, right? I just want to take the left side, so I'm only interested in Fy, so I'll take summation of moment about point A equal to 0. Let's take, because this is clockwise, right? So let's take clockwise as positive. So you'll get Fy times the distance of 4, and then this minus, so minus 40 times distance of 2, 50 goes to that, and then 30 is counterclockwise, so minus 30, distance of 3, minus 40, distance of 1.5, this one goes to point A, so equal to 0. And then if you calculate this, so just checking, F times 4, 42, 33, 41.5, then Fy you'll get 57.5 kilonewton. Verify the answer, obviously. Okay, if you use the slide, it uses counterclockwise as positive, so obviously the sign will be different. So now I have solved this one, and because I just want to take on the left side, I'll just use this one, right? So we'll move on to the second part, which is taking the left side. So if I draw the free body diagram after the cut on the left side, it's going to be something like this. This part, and then you already cut that one, right? So this one will be cut already, this one will be cut already, and then it will cut already there. So Fy is already calculated to be 57.5 kilonewton, and then you have this downward 40 kilonewton, right? And the rest is being cut. So this one, okay, I'll assume everything tension again. So you have FGH, FEH, FED. Okay, let's label it that. Right. So the dimension that is, this is 2. Okay, if I take this point here, point, what is this? Point H, and obviously this point is point what? Point E, right? Okay, so the dimension here is 2 and 2, right? So this is 2 meter. Okay, my ink is almost out, and this height is 1.5, is it? Okay, so let's, which one is easier? Okay, let's try taking summation of moment about point E equal to 0. if I take counterclockwise or positive, right? So I take about E0, so this one goes through E, this one is go through E, so I only have FGH. So FGH is counterclockwise with distance of 1.5, and then I also have this one, so this is clockwise, so minus 57.5, a distance of 2 to 0. Alright. Okay, so from here you can solve for FGH equal to 76.7 kilonewton, meaning it is in tension. Because I assume everything in tension, I got this in positive. Alright, so we have solved for FGH. If I take moment about point H, I can solve for FED, right? So summation of moment about point H equal to 0 if I take counterclockwise positive, so I take moment here, so this 2 is going through, so I can solve for FED. So in this case, minus FED times 1.5, minus because it is clockwise and I'm taking counterclockwise as positive. This 40 is counterclockwise, so plus 40 times distance of 2, this one, and then this one minus 57.5 distance of 4 equal to 0. From here you can calculate FED equal to, let's verify, minus 57.54 plus 42 minus FED 1.5, so you get minus 100 kilonewton, meaning this is compression. And then, okay, we have solved FGH, we have solved FED. So to get FEH, obviously we need the Y component, so summation of Fy equal to 0, taking upwards as positive. What is the angle here? So the angle, this is 2, this is 1.5, right? If we will multiple, this is 3, this is 4, so this is 5, right? Okay, so if we take positive Y, so this one is 57.5 upwards, this one minus 40 downwards, and then this one, right? So minus FEH 3/5 equal to 0. So if you calculate this one, you can calculate for FEH equal to, so you have 57.5 minus 40 minus FEH 3/5, so FEH become 29.2 kilonewton, which is tension. Right. So please try solving on the right side and show that it gives you the same answer. Right, I've shown for the previous example that using both sides you can still get the same answer. Obviously in the exam you just choose whichever is easier. For example, I assume this one is easier for this particular question or example, right, compared to the right side. But for exercise, for preparing for the exam, you have to try both, so that you know exactly what's going on if you need to do that one or that one, right? But of course in the final exam you should be already confident enough to be able to determine which one you want to do. But in exercise you cannot choose the easiest one and then never try the more difficult one, because that's not easy, that's not good strategy in preparing for exam, right? Okay, moving on. Okay, so I think that is it for this lecture. In the slide actually there's two more attention quiz, but basically if you understand already you should be able to answer that without any problem. And unfortunately I'm in need of my rest. It's 3 AM right now, and after this I have to process this video. I'm planning actually to make a tutorial as usual. For every of my lecture video there's a tutorial that follows it, to try different type of structures questions, so that we have multiple type of structure that we have tried, so that we are ready for any type of structure in the exam, right? So that's the best strategy, really, and to really test whether we understand the concept, because in the slide or in the lecture normally they use quite a simple problem among the many problems that exist, right, just to illustrate how to use the concept. But to be fully prepared for whatever type of question that can come in the final exam, it's best to try multiple types, right? So that's the purpose of the selected question for the tutorial normally. We'll see inshallah when I will be able to do that. So hopefully this lecture have make it clear. We have two examples that is sufficient also to understand how to solve, inshallah. So with that, thank you very much. Hopefully this has been beneficial. Do comment if you have any suggestion or anything, or to alert other students watching of anything. Wallahu alam. See you in the tutorial. Assalamualaikum warahmatullahi wabarakatuh. See you next time. See you in the tutorial. All the best.